generator and checker. Parity generator and parity checker. Okay. So what do you mean by parity generator and parity checker? Okay. So let us define first what is parity. Okay. Parity of any number. So parity of any number, parity of number. Okay. So any number can have either even parity, or it can have odd parity. Okay. So what do you mean by even parity? Even parity का मतलब है the number which is you have, okay, binary number that has even number of ones. Okay. So even parity number means okay, it has even number of ones present. Okay. Similarly, odd parity means odd number ones present. Okay. For example, if I say 1 1 1 1 0 0 1 1 1 0 0, okay, so it has a 1 2 3 4 5 6 ones are present. So this is your even parity number. This is your even parity number. Okay. And similarly, if I write 1 0 0 1 0 0 1 0 0, okay, it has a 3 odds. So 1 2 3 4 5 6. Okay, so 6 ones. Okay, so this is a even parity. It has a 3 ones, odd number of ones. So this is your odd parity number. Okay. Now, how to generate a even parity number? If you have some number is given, okay, so 4-digit number is given. Now you want to convert this all number in every even parity numbers, or you want to convert them odd parity numbers. Okay, then you have to generate the even parity number, okay, and odd parity number, or even parity bit and odd parity bit. Okay, what does mean? ये clear है बताओ? Is this clear?
Sir,
हाँ.
Sir, my connection was little bit not okay, just last 3.
मैं ये बता रहा हूँ कि पैरिटी दो तरह की होती है, इवन पैरिटी और ऑड पैरिटी. इवन पैरिटी का मतलब किसी नंबर की पैरिटी का इवन है तो उसके अंदर इवन नंबर ऑफ वन होंगे, और ऑड पैरिटी है तो उसके अंदर ऑड नंबर ऑफ वंस होंगे. दैट्स इट. ओके. सो now how to check whether a number is odd or even? Okay, so we want to generate as well as we check. Okay, so put even parity generation. Okay, generation. So how will generate? Okay, so for example, I have a 4-digit numbers. Okay, four numbers. Okay, so this is different combinations. This can give me different numbers. Okay, 0 0 0 0 4 5 6 7 8 1 1 1. इसमें देखिएगा 1 थोड़ा ऊपर से जाएगा. If it's not visible here, say this is my A, B, C, D. Okay, so say this is my 0 0 0 4 5 6 7 8 1 1 1 1 1 1 1 1. Okay, so this is your first, second, third, fourth, fifth, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have a this number 0, 0, 0, 0, 1, 1, 1, 1, 0. So all combinations of writing 4-digit combinations 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay. Now, if I write, okay, now if I give this input to a XOR gate, okay, so XOR gate is basically used for parity checker and generator, okay. So XOR gate, okay, XOR gate is basically used of, so suppose I have a input AB. So if I give input AB to AB, I should give to here, okay, then I'll get some output. Then there is a C, there is a one more XOR gate, and this output I'm giving, here, and C input is coming. I'm getting some output here. Okay. So I am generating even bit. Okay. Even parity bit I'm generating. Even parity bit. Parity bit generator. Okay. And then I will put one more XOR gate and I put D here. Okay. So this is basically what? This is basically I am putting A, B, C, D to here. Okay. So this will give you A XOR B. Okay. This will give you A XOR B XOR C, and this will give you what? A XOR B XOR C XOR D. Okay. Now you know what you mean by A XOR B XOR C D. Okay. So now if I write a parity here, a parity bit here, output of this one. So I'm saying the output of this is equal to your P, and this is your even parity bit. I'll tell you how. Okay. So this is your, so in XOR gate, whenever you have odd number of ones, you get ones here. So here's 0, you get 1 here. You get 1 here, you get 2 0, you get 0 here, you get 1 here, 0 here, 0 here, 1 here, 1 here. This you got 0 here. Then you have 1 0 1 0 1, 0 here. Okay. Then you have a 1 1 1 1 0 1 1 1. Okay. Then 4 1 0. So whenever you have odd number of 1 present, okay, we know the XOR gate will give the 1. Okay. So this is your even parity. P is what? P is your even parity bit. Even parity, even parity bit. Okay. So why it is called even parity bit? Now if I have a 4, this one, so this output P. Okay. So if I take one more, this is even parity generator. Now I want to check even parity checker. Even parity checker. So what I'll take this output. Okay, I'll take this output here. So this is a P is coming here, and all A, B, C, D I will put here. A, B, C, and D in another XOR gate. Okay. So what will the output? What will the output tell me? What will the output now? Suppose I put 0 0 0 0. Okay, along with this parity 0. So what will come? What will the output will come?
0.
0. Okay. Now if I put output here, I put this one 0 0 0 1 along with 1. What will
Zero.
the output? 0. So even now anything I'm sending here, okay, I'll get the output. I'll get the output 0. Okay. So if f is equal to 0, okay, I can say these all numbers are what? They are this number. Now this all number combined together is what? Even parity number. Even parity number means there should be 0, 1 or even number of ones. So see, here 0, 1, here 2, 1, here 2, 1, here also 2, 1, here also 2, 1. Okay, you 2, 1. So wherever earlier it was odd, 1 will come. Combined together, the total number will become what? Even parity number. So if now you all the inputs you are putting with this p, if you are getting f is equal to 0, that means this number, what number are coming, they are all with even parity, so there's no error. This will check you no error. Okay, if somehow if f comes 1, then that number is not your even parity number. Okay, so that will be your error. Okay, that's why this is called your parity checking, even parity checker. This is called your even parity checker. Okay, so this way you can generate any even parity bit. Even parity bit is the bit, okay, when it combines with the combination, okay, given combination, it makes them even parity number. तो अभी ये जो ABCD के साथ इसको कंबाइन करोगे तो सारे इवन पैरिटी नंबर बन गए. So this is called even parity bit generation, and this is called checking. Checking means you have to put this bit also with along with inputs. If you have 0 coming, that is all numbers are even parity number. Checking, and if it's n, some is error. Okay, ask if any question. Any question?
सर
हम्म,
सर ये पेरिटी चेक करने के लिए हमेशा हम लोग एक्सॉर गेट का यूज करेंगे ना?
एक्सॉर गेट का पैरिटी चेकर है. एक्सॉर गेट यूज फॉर पैरिटी चेक. जनरेशन के लिए भी हम वो करेंगे एक्सॉर गेट, एंड चेकिंग के लिए भी एक्सॉर गेट.
ओके.
हाँ, कोई और क्वेश्चन? Okay, so this is simple, very simple. So this is your parity generation, okay, using XOR gate. Now this is an even parity generator. Now if I want to generate odd parity generator, the same circuit will be there for odd checking and generation. So if you want odd parity generator, okay, so you want odd parity bit generation, odd parity bit generation. Okay, so the bit which combine with other combination makes them odd parity number. That's like p bar. So p bar will be what? Opposite to this one. Okay, so wherever 0, it will come 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0. So this is exactly opposite. Okay, so if you want to generate, so the circuit is same. You take A, B, okay, you give C here, you give D here, okay, that will give you now put here in. So this is A XOR B, this is A XOR B XOR C, okay, and this is your finally P, or P means what? A XOR B XOR C. D, you put a AND gate here, so this will give you P bar, and this is your odd parity bit. This is odd parity bit, okay. So P is your even parity bit, okay, and P bar is your odd parity bit. Okay, now whenever you combine P bar with this number, these all become your odd parity numbers. So whenever you combine this P bar, with A B C D, A B C and D, okay, you get some output F. If output is 1, then there is no error. All are odd parity. If f comes 0, then this is the error. Okay. So in this way, you can generate a odd parity number and you can check. Clear? सिंपल, ज्यादा कुछ में है नहीं इसके अंदर. Okay. So shall I erase this one?
Yes, sir.
Okay. Now put the heading encoder and decoders. Okay. So encoder का मतलब क्या है? Encoder means simply which codes. Okay. So when we code something like decimal to binary, octal to binary. So once you code, we need encoder. Okay. If you want to decode, so then we need decoder. Anything is coded, you want to decode from one number system to another number system. Okay. So first put encoder. Okay. Encoder. What is encoder? Okay. So this is your block diagram of encoder. Okay. So encoder is basically what? It has a multi-input and multi-output logic function. Okay. So it has a many inputs and many outputs. Okay. So logic function. Okay. So multi encoder is what? Multi-input and multi-output logic function or logic circuit. Okay. It has a multi inputs and multi outputs. Okay. So for example, it has a m inputs. Okay. For example, it has a m inputs. And m inputs like D0, D1, okay, D3, and so on up to DM. And it has a n inputs. It has an n bit output. Okay. So say this is A0, A1, AN, n bit output. Okay. So out of n inputs, okay, only one input will be high at a time. Okay. Only one input will be high at a time. For example, I want to make a octal to binary decoder. Octal to binary decoder means I want to convert eight lines. Okay. So octal means 8 lines. So 8 line to 3 line binary. So you know any octal number can be represented by 3 binary numbers. Okay. We have seen like any octal number can be represented by 3 binary number pair of 3 binary numbers. Similarly, hexagonal number can be represented by 4 binary numbers. Okay, so this is called your 8-line to 3-line decoder. Okay, so that means
encoder या decoder?
एनकोडर. ओके, हम कोड कर रहे हैं ऑक्टल नंबर को बाइनरी में कोड कर रहे हैं. ओके, कोड किसी भी कर सकते हैं, जैसे कोड है उसको वैसे डिकोड करेंगे. सो आई एम कोडिंग नाउ. So 8 lines. So here, suppose here 8 lines, and 8 lines I am coding in binary, that 3 lines. Okay, this is called encoder. Okay, so this is called 8-line to 3-line encoder. Okay, so just make me one table to make you understand what is the meaning of this encoder. So only one input will be high at a time. So let me explain this one. इसको erase कर दूं? सिंपल, कोई मुश्किल नहीं है, बड़ा आसान है. डिकोडर एनकोडर बहुत सिंपल है. जैसे द वे यू आर थिंकिंग, okay, according to that you have to perform here. Okay, so you have an octal number system. Octal digits are there. Okay, and I'm representing this octal digits by, say, 8 digit. I am representing by it D0, D1, D2, D3, D4, D5, D6, D7, D8. Okay. D7. Okay, and this is equal to 0, decimal 0, 1, 2, 3, 4, 5, 6, 7. Okay, now I want to represent this number into binary output. Okay, so I want to represent this as a binary output. So say I'm taking A1, A2, A1 and A0. Okay, so this is my output. So you have 8 lines and you get 3-bit output. Out of 8 lines you get 3-bit output. Okay, so now coding का मतलब क्या है? First we need to make truth table. Okay, so 0 means I know 0 means 0 0. If I want to code D0 as a 0 0 0. Okay, I want to code D1 as a 0 0 1. D2 I want to code as 0 1 0. D3 I want to code as a 0 1 1. D4 I want to code as a 1 0 0. D5 is your 1 0 1. D6 is your 1 1 0. D7 is your 1 1 1. So this way I want to code. So what is the circuit encoder? Okay, so obviously now once I have A2, A1, A0, I can write this as a function of these terms, D0, D0, D1 in the form of these terms. Okay, so wherever 1 is present, which is my one min term present, okay, that is present here. Okay, so you can write A2 equals to 1, so you can write A2 equals to D4, D5, D6 and D7. Okay, wherever it's present. Similarly, you want A1. Okay, A1. So A1 is basically your D2, D3. Okay, then you have D6, sorry, D2, D3, and then you have a D6, D7, D6, D7. Okay, similarly, I want to write A0. So A0 will be my D1, D3, okay, D1, D3, D5.
सर जिसमें 1 है वही आप
वो जिसमें 1 है वही लिख रहे हैं, जिसमें 1 है वही लिख रहे हैं, D7. Okay, please check it whether it's correct. Not D4, D5, D6, D7, D2, D3, D6, D7, and then your D1, D3, D5, D7 is correct. Okay, so now can you make the logic circuit for this one? So simple, you have what, OR gate only. So you have 3 numbers A1, A2, A1. Now you need to make encoder circuit. So I need 3 OR gates. Okay, for one for A2, one for A3, so I need 3 OR gates. This will give me A2. This will give me A1, and this will give me your A2. Okay, now I have here D0, D1, D2, D3, D4. cut रहा है वो. So from here D0, D1, D2, D3, D4, D5, D6, D7, D8. Okay, so these numbers I have here. Okay, and I have here this one OR gate. Okay, I want A2, A1, A0. Okay, so your A2 is basically A2 is basically D4, D5, D6, D7, D4, D5, D6, D7. Okay, so your D4, D5, D6, D7. Okay, similarly you want A1, so A1 is basically your 2, 3, 6, 7, 2, 2, 3, 6, 7. Okay, so A2 is where D4, 5, 6, 7, and A1 is your D2 plus D3 plus D6 plus D7, and A0 is 1, 3, 5, 7. So 1, 3, 5, 7. Okay, so 1, 3, 5, 7. Okay, so if you carefully look this one, okay, I have 8 terms from 0 to 7. Okay, and D0 we are not using anywhere. Okay, so D0 is called your don't care condition. D0 is your don't care condition. Okay, now I told you that encoder means what? Encoder means, okay, there will be only one input will be high at a time. Okay, so there will be one input high, at a time. Okay, so let's make say I'm making 7 is a 7 as a 7 is a high, and all others are 0, 0, 0, 0, 0, 0, 0, 0. Okay, so if I make D7 1, okay, automatically the number is your A2, A1, A0, so your A2 become 1. Okay, it is correct. Here D7 is there. Check it. A1 में D7 है क्या? Is the D7 present in A1 also?
Yes, sir. Yes, sir.
Is present.
Yes,
Okay.
sir.
Okay. So just 1 minute. D60 75 or okay. So if I put A2 equals to 1, okay, and D7 equals to 1, so this become 1. Okay, A1 become what? A1 become also 1. Okay, and A0 also become 1. Okay, so this is what? Coding of 7. Okay, this is octal number or 7 number, and the 7 number D7 will be code like your 111. Okay, you make anything output is input is high. Okay, then automatically this will be stored in the form of your binary number, because it's the we are doing octal to binary encoding. Okay, so let us say I make 4 as a 1. Okay, I'm making now 4 as a 1. 4 as a 1, others are 0. Okay. So 4, once I make 4 here, automatically my A2 becomes 1. Here 4 is not there, so this A1 becomes 0, A0 becomes 0. So this is stored like a 1 0 0. Okay. So in this way, you can, by using this circuit, you can code. Okay. So D7 will be code like a 1 1 1. This is coding. You're coding in a this n bit output. N bit output. So you're coding in 3-bit output. You have 8 lines and you're encoding in 3 bits. That's why it is called 8-line to 3-line decoder encoder, and line to 3-line encoder. कोई क्वेश्चन है इसमें? इज इजी ना?
एक
लक्ष्मी?
मिनट सर,
हाँ।
आउटपुट देखेंगे
हम्म।
सर। लाइक जब हमने D4 को 1 किया है तो
ये 1 हो गया, A2 1 हो गया,
A2 1 हो गया
और D4 और D4 और का है ही नहीं,
नहीं है तो 0 0
0 0 1 0 0 हो गया. So is this way you can code any number in binary, octal to binary. Okay. Now ये तो था octal to binary encoding. Okay, I want to do decimal to binary encoding. Okay, तो decimal में कितने digit होते हैं? 10 digits, 0 to 9. Okay, and if you want to encode in binary, okay, so there should be how many bits should be there in binary number? Like here I have done 3-bit. Okay, if I want to encode in binary, decimal to binary, then it will be what? 10 line to 4. Very good. Because if you want to write 9 or 10, you want to write 10, then you need 101. You need 4-bit. Okay. Now 10 will be not there. 0 to 9. If you want to write 9, this will be 1001. Okay. If you want to write 8, so 8 will be what? 1010. So you need at least 4-bit. Okay. So now put the heading decimal to binary decoder. Okay. Decimal to binary decoder. Encoder, sorry. Okay. So decimal to binary encoder, and this is called your, because your 10 lines, 10 input we have 10 lines, 10 line to 4-line encoder, because you need 4-bit binary number. Okay, make the table like I made. Okay, this time you have a 4 digits. You have this time A3, A2, A1, and you have A0. Okay, and here you have octal and decimal. Okay, you will be having decimal means what? 0 1 2 3. Okay, digit will be up to D0 to D9, or you can add 0 1 2 3 also. I'm adding D0. Okay, then 10 symbols: D2, D3, D4, D5, D6, D7, D8, D9.
So after A1 you have written A0, no?
A3, A2, A1, A0. Okay, so this is binary. This will be 0 0 0 0 0 0 0 1. Okay, so this will be what? 0 0 1 0 0 0 1 1. Okay, then 4 0 1 0 0, then 5 0 1 0 1, then 6 1 6 will be what? 1 1 0 0. 7 will be what? 0 1 1. 1.
No, sir. D6 0
Ah,
1.
okay. So this will be what? 5. 5 is correct. This is what? 6 will be what?
0 1 1 0 maybe 0 1 1 0
0 1.
1 0.
This 6. 2 power 1, 2 power 2.
No, sir.
power-
2 power 0 here.
2 power
0
2.
1 1 0.
1 0. This 6.
0 1 1 0.
0 1, sir.
0 is a 0.
Yes, sir.
0 1 1. Okay, correct. Thank you.
Yeah.
2 4. Okay. 7 0 1 1 8. 8 will be 1 0 0 9 1 0 0 1. Okay, thank you. So this is your, okay. Now you can write A3, A2, A1, A0. Okay. Tell me what will be A3?
D8 plus D9.
D8 plus D9. Very good. What will be A2?
D4, D5, D6, D7.
D4, D5, D6, D7. Okay. And A1?
D2, D3, D6, D7.
D6 and
D7.
D7. Okay. And A0 will be D1 plus D3 plus D5 plus D7 plus D9. Okay. So this is the function. Okay. Now you can find anything. Okay. If you put here, say D4 is 1. D4 is 1, other 0. So this is the A3, A2, A1, A0. So A3 becomes 0. D4 I'm putting 1. A2 become 1. A1 becomes 0. A0, D4 is not there as 0. This become 1 0 0. So this is correct. Okay. So this is 1 0 0. Let me take D6. 6 is high. So 6 is high means A3 0. A2 is 1. A1 is also 1. A0 is 0. So 1 1 6. So this is coding correct. Okay. So this is your 10 line to 3 line encoder. Okay. Now circuit is easy. Okay. Circuit you can make. So let me make the circuit. Circuit is simply OR gate, nothing else. So let us make. Okay. So this is your homework. Asana isme no need to. I don't need to draw. Okay. Just you draw and send me in 5 minutes. So decoder we are not starting. It will take half an hour. Decoder is important. Okay. So this is very simple thing. So decoder we will do tomorrow. So meantime you can draw a circuit and send me. Let me check if I have any problem of encoder. I'm stopping here. Okay. Thank you.
Thank you, sir.
Question तो नहीं है. Question is there?
सर
हाँ.
सर मेरे माइंड में ये चल रहा है सर हमने जो नंबरिंग की
हाँ.
A3 A2 A1 A0 की
हाँ. हाँ.
that was our previous knowledge that we are like we take 0 0 0 first 0 number 1 number 0 0 0 1 and जब हम वहीं पे तो हम 1 पुट कर रहे हैं तो वो तो आएगा ही ऑटोमेटिकली D6 मतलब लाइक वो A2 पे 1 ऑलरेडी आएगा ही आएगा, जैसे
हाँ
D6
हाँ,
में पुट ही कर दिया तो
तो भी
वो चीज।
मेन तो जो लॉजिक हम जानते हैं वही तो आपका सर्किट भी तो वही लॉजिक देना चाहिए ना। मेन तो एनकोडर डिजाइन का मतलब क्या है? डिजाइनिंग डिजाइनिंग सर्किट। ओके, तो अगर मैं एक भी इनपुट को हाई करूं, सपोज मैंने यहाँ पे सर्किट बना दिया, सपोज आई एम सर्किट, अब वो चेक कैसे करोगे? वो तो मशीन में कैसे यूज करो, दैट इज डिफरेंट थिंग। ओके, व्हाट एवर लॉजिक इज देयर, दैट circuit should perform the logic. Okay, now suppose in this particular case you have four OR gates. Okay, now suppose I am making any number, say I just making six is one here, 6 is 1. Okay, I'm making y high input, I'm giving 5 or I'm giving 10. Okay, so automatically suppose here I am putting LED in each this one. Okay, now circuit should tell me na, I am not doing it mathematically kar liya. By doing mathematically I have designed the circuit. Now basically this circuit is decoder encoder or not. Okay, I want to check. Now I make D6 1. Okay, so as soon as I make D6 1, this light will become red. Okay, and this become red. Correct na? 6 means what? 110. Okay, so
Yes, sir.
this
Yes, sir.
and this will not blink. So automatically this circuit is coding na. So this is a low point, this is high point, this is a high point. That means high point. Okay, so you're getting 110. Okay, so this is your what? A2, A1, A3, A2, A100. तो आपको ये सर्किट बता रहा है ना आपको आपकी कि ये नंबर क्या है। ओके,
Okay.
डिजाइन तो करना
Okay.
पड़ेगा ना।
Like
डिजाइन
previously, we don't have the knowledge about that
हाँ
6 is a 0 1 1 0,
हाँ हाँ,
and we are giving
see
on the
that just for I am doing reverse by
okay, okay.
I'm making knowledge, this one I'm making a circuit. But we are in reality we have a circuit, and this circuit
Okay.
is performing functions. I am making at a time one. Okay,
Okay, sir.
जिसको जिस नंबर को मैं हाई कर रहा हूँ वो मुझे इस तरह दे रहा है, उसको समझाने के लिए मैंने पहले से ड्रॉ कर दिया ताकि आपको ये ड्रॉ करना आसान हो जाए। ओके
Okay, sir. Okay, sir.
ओके, थैंक यू।